Now that you've watched the video on faults and folds, let's see how you do at this picture I showed you earlier. You'll notice that the faults are dipping, they're not vertical. So these are dip-slip faults, and this is the main trace of the main fault. This person is down here for scale. Let's think about hanging walls and foot walls. Hanging walls are always going to be above the fault trace, and foot walls are always going to be below the fault trace. So we can label the hanging wall and the foot wall. Now let's think about which side moved relative to the other. We can see this change right here from a red unit to a gray unit, and that change is also up here from red to gray and here from red to gray. So this contact, which used to be continuous and horizontal, has been offset with the hanging wall moving down relative to the foot wall, which moves up. By definition, this is a normal dip-slip fault. Let's take a look at some other dip-slip faults in your lecture tutorial. The first question says to label the hanging wall and foot wall in each of the fault diagrams. On the left here, the fault again is dipping, so above the fault we always have the hanging wall. Below the fault we always have the foot wall. Over here, same situation. Hanging wall is above the fault and foot wall is below it. When we determine the hanging wall and the foot wall sides of a fault, it doesn't matter what kind of dip-slip fault it is. If it's dipping, then we just look at what's above and what's below the dipping fault. Now it says to draw arrows showing the movement along each fault, and this one is a little trickier. We need to look again at units that were once continuous across the fault and now have been offset. If we look at this unit here, this thick dark gray unit, and then a thick white unit, and then a skinny gray unit, that seems to repeat over here. Thick gray, thick white, skinny gray. So it looks like the hanging wall side has gone up relative to the foot wall side. On this diagram, we have the opposite situation. Here's a skinny white, and thick gray unit, which is repeated down here. Skinny white, thick gray unit. So in this case, the hanging wall seemed to have gone down relative to the foot wall. Based on the direction of movement, label each diagram as a thrust or reverse fault and a normal fault. As you learned in the previous video, reverse faults occur when the hanging wall goes up. A thrust is a type of reverse fault that has a very shallow angle. The fault plane might be oriented like this. For our purposes, we're going to just call them all reverse faults. Over here we have a normal fault. Hanging wall goes down relative to the foot wall. One way to remember this is to think about this fault as an actual hill. And if something was rolling down a hill, then normally it would go down. That's a normal fault. You wouldn't have something go up a hill. That would be going against gravity. And in that case, it's reverse. So that's one way to think about it. Or you can memorize that the hanging wall goes down. What type of fault is drawn in the left diagram? Well, let's think about which wall is the hanging wall and which wall is the foot wall again. Here's the fault trace. So the hanging wall is above it and the foot wall is below it. Which side went down? If we look at this very dark unit, we can see that the hanging wall went down relative to the foot wall. And so by definition, this is a normal fault. What about the one on the right? Here we have the hanging wall on the left, foot wall on the right, and that's because the fault is dipping in a different direction from this one. It looks like the hanging wall went up relative to the foot wall. If we look at this dark unit, that would be a thrust or a reverse fault. What type of stress is shown in the upper left diagram? Tension creates normal faulting. It pulls things apart from each other. Over here, where things are being pushed up and over, we have compression. We can indicate the stress direction with arrows. On normal faults, tension indicates things being pulled apart. On reverse faults, compression indicates things being pushed together. On the map shown here, They want us to draw arrows to show the direction that things are moving on each side of the two plate boundaries. So this plate boundary here is divergent. Divergent is where things are being pulled apart. This boundary over here, according to the key, is a convergent boundary, and that's where things are being pushed together. Label locations A and B with normal faults or reverse faults. Well, since we have regions of tension along this divergent boundary, we're going to have normal faults. Since we have compression along this boundary, we're going to have reverse faults. Normal faults always form in regions of tension. Reverse faults always form in regions of compression. Finally, it asks you to look at these diagrams and figure out which one would go with A and which one would go with B. This one, we determined above, is a reverse fault, so it should go over here at location B. This one is a normal fault, so it should go over here with location A. Coming up next, earthquakes.